Class example 4.3.2. So we're asked to find the x and y intercepts for the following equation, and then we're going to graph it. Okay, so this one's actually not as bad as you think. What we can do if we want to find the x and the y intercepts is just think about what the value of y and x would be at those places. So just for a second, let's imagine that this is our line, right? I know it's not, but it just helped to demonstrate this. So if I want to find, let's say, the y-intercept on this one, can you see what the value of x would be at the y-intercept? Well, the value of x, right, because these are my x values going along the bottom, at the y-intercept would be equal to 0. So what I should be able to do is just throw 0 in for x and then solve for y. Okay, so that's what we're going to do for that one. And then while we're at it, think about what the value of y is at the x-intercept, right? So these are my y values, up and down. Well, at the x-intercept, my value of y is 0. So if I want to find my x-intercept, I'm going to throw 0 in for y and then solve for x. Okay, so this wasn't my graph, so let's actually figure this out now. So like I said, so for the x-intercept, so x-intercept, what we're going to do is we're going to rewrite this, but instead of an x, I'm going to throw, for the x-intercept, I'm going to throw a 0 in for my y. So we're going to rewrite this as 3x minus 4. And like I said, instead of a y there, we're going to throw a 0 in. And that's equal to 12. Now, zeros are nice because anything times 0 is just 0. So this whole term here just cancels. So what we have left now is 3x is equal to 12. I need x on its own, so I got to get rid of this 3 that's being multiplied by x right now. So I have to do the opposite of multiplying. We need to divide. So we're going to divide by 3, so we get x is equal to 4. Okay, so perfect. What does that mean? Well, what I just found is that when y is 0, x is 4. So that's my first point. That's my x-intercept I just found. Okay, so we're kind of doing both at the same time. We're graphing this equation as we go. All right. So now let's find the y-intercept. As you can guess, it's going to be very similar. But this time, what I'm going to do is I know that at the y, on the y-intercept, my x value is equal to 0. So we're going to write this out. So it'll be 3, and then instead of an x, I'm going to throw in 0. And then minus 4y is equal to 12. Okay, so then 3 times 0 is just 0. So what I have left is 4y is equal to 12. Now, I need to get rid of this negative 4, right? Any y on its own. A mistake that may happen here, I've seen students do quite a bit, is they would add 4. But that's not right. Because if you think about it, what we're doing here, we really have negative 4 times y, right? So we need to do the opposite of what's being done. So we need to divide by a negative 4. If you think about that, right, that's negative 4 divided by negative 4, that's positive 1. So that like got rid of it or canceled it. But then whatever you do to one side, you have to do the other. So those cancel. So now we have y is equal to, and then 12 divided by negative 4 is going to be negative 3. All right, so what does that mean? That means that we have a y-intercept at negative 3. So perfect. So now we have 2 points, right? So now if we want to graph this equation, all we got to do is connect the points. And for good measure, I never really did write these as points, so let's do that too. So on the y-intercept here, this was the point 0, comma, negative 3. And our x-intercept was 4, comma, 0.